So here we're just going to take a look at a couple of trickier questions involving the chain rule that we didn't take a look at in the other lessons. So here we're given this really complicated function here, and we're asked to find the derivative. This is going to involve application of the chain rule. And in fact, we're going to have to apply the chain rule more than once here. So first, let's start by looking at sort of how let's start thinking about this in terms of what simpler functions make up this complicated function. So our entire big function here has got two parts to it. There's this part here in square brackets minus this 3x here. So we know how to take the derivative of two functions that are subtracted. We do the individual derivatives, and then we just subtract the individual derivatives. So we know that our derivative f prime dot x is going to be the derivative of this big complicated thing here first, okay, minus the derivative of 3x. Well, the derivative of 3x is just going to be 3. So it's just going to be derivative of this, and I'll just write it down here, minus 3. So now we have to do the derivative of this first term here, which is this thing in square brackets to the power of 5. So we're going to have to use the chain rule. So let's start using the chain rule here. We're going to bring down the 5. Okay, and we're going to keep the thing in square brackets exactly the same. 2x squared minus 3 times x cubed plus 4x to the power of 4, all squared. Subtract 1 from our exponent. And we're halfway there. Chain rule says that we do derivative of the outer function and we multiply it by the derivative of that inner function. So we need to take the derivative of this thing in here. Well, this has got two functions that are subtracted from each other. We've got one function right here, and we've got another function over here. So the derivative, what we're multiplying by, is going to be, let's see, the derivative of that first term is 4x, and we want to subtract the derivative of that second term. Well, that second term in there is itself a composite function. So we've got to use the chain rule again. So chain rule says we bring down the 2, multiply it by the 3, so that'll give us a negative 6. Keep the inside part the same, x cubed plus 4x to the power of 4. Subtract 1 from our exponents, we'll just have a 1, and then multiply by the derivative of what's inside. Well, the derivative of what's inside there is going to be, this is multiplied by, let's come down here. What is the derivative of that thing that is inside? Well, the thing that is inside is now this function here. So we're going to have 3x squared plus 16x cubed. So that closes off that bracket. We'll close off that bracket, and then we can move this minus 3 up there. So there is our derivative. Okay? And basically you want to start on the outside of your function and work your way in. Our outer function was something subtract something, do the derivative of both of those. Next step in, we've got something to the power of 5, do that derivative. Multiply by the derivative inside, derivative of this, and so on and so on. Now, our next example we're going to look at here is what if you're given a question where you're not told specifically what the functions are. So we're asked here to find an expression for f prime dot x, or find the derivative of our function in terms of x, g at x, and g prime dot x. So our first one here, f at x, is x cubed times g at x. I don't know what g at x is, but I know that what I have here are two functions that are multiplied by each other. So I'm going to have to use the product rule to get my derivative. So I'm going to define my first function u as being x cubed, my second function v as being g at x. So my derivative, f primed at x, is going to be u primed times v, so 3x squared times my v function is just g at x, plus my original u function, which is x cubed, times the derivative of v. Well, I don't know what v is, it's g at x, but the derivative of g at x is g primed at x. So that's my expression for f primed at x. And notice that it's expressed in terms of x, in terms of g at x, and in terms of g primed at x. So let's do another example here. f at x equals g of 4x squared plus 2x minus 1. So in this case, my two functions aren't multiplied by each other. They've been combined using composition. So I'm going to have to use the chain rule here to do my derivative. So chain rule, remember, we're going to be using, think of this as f at x is equal to g at u. So in this case, so my derivative, f primed at x, is going to be g primed at u times u primed. So what is u? U is this inner function inside here. So my derivative here, f primed at x, is going to be g primed, okay, because g is my outer function, so g primed at u. U is just that 4x squared plus 2x minus 1 times the derivative of that inner function. So what's the derivative of 4x squared plus 2x minus 1? 8x plus 2. And there's my derivative. So one more example of this. F at x equals the square root of g at x squared plus 2x squared plus 3. Let's rewrite this a little bit, getting rid of that square root symbol and turning it into an exponent of 1/2. So this will be g at x squared plus 2 at x squared plus 3, all of this to the exponent 1/2. We're going to have to use the chain rule here to get our derivative. So our outermost function is everything to the exponent 1/2. So we're going to bring down that 1/2, keep everything inside the bracket exactly the same. So g at x squared plus 2x squared plus 3. Subtract 1 from our exponents, we get an exponent of negative 1/2. Chain rule says that all of that gets multiplied by the derivative of what's inside. So what is inside? We've got g at x squared plus 2x squared plus 3. So we can just do this derivative term by term. Derivative of the first term plus the derivative of the second term plus derivative of the third term. So what is the derivative of that first term? Well, that first term is itself a composite function. It's made up of the function g with x squared subbed inside. So we've got to use the chain rule. Derivative of the outer function is g primed, evaluated at the inner, times the derivative of that inner function, 2x. So that's the derivative of our first term. Now we need the derivative of the second term, so we're going to add on. See, derivative of 2x squared is 4x. And the third term there is just a constant, so it's going to go away. So that's our entire derivative expression right there. And for a question like this, I wouldn't bother simplifying it. I would just leave it just like this, because we're not really interested in simplifying this. It's more a test of, can you apply the chain rule to a question like that?